Alright, so I think this is recording. We're looking at skill packet 5, exponential and logarithmic functions, and in this skill 5F, we're solving log equations. You definitely need to know your properties of logarithms, those formulas that are in the skill packet, in order to do these. On the left-hand side, well, first of all, notice that all of these logs have the same base, a base of 4, so our properties, we can use them. On the left-hand side, we have the sum of two logs. And you know what? Actually, when I look at this, I can subtract this log of 4 of x and get all the logs on one side and then this number on the other. So that's what I want to do. I've got log base 4 of x plus 5 plus log base 4 of 6 minus log base 4 of x is equal to 2. So now I can write this string of logarithms here as a single logarithm. If I go from left to right, this sum right here, I can write that as a single logarithm using the product rule. Log base 4 of 6 times x plus 5. And then I have minus log base 4. So by the quotient rule, if I have the difference of two logs that obviously have the same base, then I can write this as a single logarithm. I've got the log base 4 of 6 times x plus 5 in the numerator and divided by x in the denominator. And that is equal to 2. So I've gone as far as I can go with my properties of logarithms, and I can recognize now that this is in logarithmic form and I can change it to exponential form. Now I could do log base 4 of 16 because that's equal to 2, but that's sometimes harder for some students to see. So let's just rewrite this log form as an exponential equation. 4 squared is equal to, well, I'm just going to go ahead and distribute now, 6x plus 30 divided by x. So if I write this over 1, I have a proportion. And one technique to solve a proportion is to cross multiply. So if we do that, and let's do that over here, along one diagonal, 4 squared is 16, so we get 16x, and along the other diagonal, we have 6x plus 30. So now if we solve this to get x by itself, I get that x is equal to 3 if I haven't made a silly mistake. Now, make sure that by plugging 3 in that we don't take the log of 0 or the log of a negative number. 3 plus 5 is positive, 3 is positive, so hey, this is the solution to this equation. So let's go ahead and do the next one. Similar idea here. We have two logs that have the same base. We have our properties of logarithms that say if you have the sum of two logs, you can write it as a single logarithm. If you take the product, x minus 5 times x minus 4, and that's equal to 1. I could rewrite that 1 as log base 6 of 6, but probably it's just easiest for students to change this logarithmic form to exponential form. So we have this base of 6, a logarithm equals an exponent, and now we need to multiply x minus 5 times x minus 4, which is x squared minus 9x plus 20. That's a quadratic equation. Let's get it in standard form, and hopefully we can factor it. If not, we'll have to use completing the square of the quadratic formula. Subtract 6, and I get 14, and I believe now that I can factor it when I look at these, because two values that multiply together give me positive 14, but add together give me negative 9. Those are two negative numbers. If I have x minus 2 and x minus 7, that should do the trick. I get possible solutions of positive 2 and positive 7. However, when I plug in positive 2, 2 minus 5 is a negative number, so is 2 minus 4. That's not going to work. That's extraneous. Plug in 7. 7 minus 5 is positive. 7 minus 4 is positive. Hey, I know that's the solution to this equation. So I hope that helps, and I will talk to you later.